Okay, so this is about quadrat sampling. So I gave the definition for a population in the first video about the vocabulary. And so quadrat sampling is a way of estimating the population of certain species in an area. So the idea is that you mark off, so if you want to know, if you want to estimate the population of trees in this field, you don't want to have to count every single tree. Right? And so instead what you do is you mark off a certain area of the field, and then you make grids. So usually these are kind of 1 meter marks, right? So this would be 1, 2, 3, 4, 5, so 6 meters by 6 meters. And then you randomly place your quadrat, and a quadrat is literally a metal, just a metal square or plastic square, all right? And it's usually 1 meter by 1 meter. It can also be half by half. But anyway, so you place it down, and the idea is you place it randomly. So you want to use a random number generator to choose where to place the quadrat, all right? And then you would count. So how many species, how many individuals are within that quadrat, okay? So these are already graded, and then you would repeat that. So the idea is that you mark off an area, and then you place the quadrat randomly. Randomly, keyword, okay, the idea that it's random, don't just throw it, that's not random. Anyway, so use a random number generator, something like that. So you place the quadrat randomly. You do this by, if you're doing random number generator, I would generate 2 numbers. So maybe I do a 6 and then a 1. So I'd go over 6 and up 1, so it would be this square right here. Okay, so you place the quadrat randomly, and you count the number of individuals of that species. So here, there's 1, all right? Then, and then you repeat that process. Usually you do it about 10 times, ideally. All right, and so then the idea is like you get, so this, if you can see which ones are grayed in, right? So 1, 2, 3, 4, 5, 6. So they did it 6 times. And so I have 1, I have 4, 3, 3, and 2. So if I add those all up, I get 13, right? So you repeat, and then you add to get your total. And then you're going to take that total and you divide by the number of times you did it. So you divide by the number of repeats that you did. All right, let me screw this up. All right, so you divide by the number of repeats that you did, and then you multiply to get to cover the entire area. So the example for this would be if I have, so here in my, I have 4, I have 1, I have 3, 2, and 3. So that's 5, 8, 12, 13. So I have a total of 13. That's how many trees I counted here. And then I divide by the number of repeats. This was done 6 times. So 13 divided by 6, that's going to be 2 point something. Hold that thought. We'll call it 2.2. All right, so that is 2.2. So on average, there are 2.2 trees in every square meter of this. Now, I said this was a 6 by 6 grid, so there's 36 total squares within this grid. So I take my 36 and I multiply by 2.2. That's what I mean by multiply by the entire area, and I get 36. I get 79.2. So there are about 79 trees in this entire area. All right, so that's quadrat sampling if you want to estimate a population size. Now, the other thing that you need to know how to do this with this is to compare biodiversity. Biodiversity is how many different species there are in an area. I'll write down the definition of this. All right. So how many different species there are in an area, but not just how many species, but also how many individuals of each species. So there might be 10 species, but if you have 100 of the first species present and then only 1 of each of the other species present, that's not terribly biodiverse, right? So this is the number of species present in an ecosystem and the number of individuals of those species. And this is something called species richness and versus species evenness. But those two are, I'm not writing those down because those are terms you meet in A level. All right, but that's really what we're talking about. The number of species present and the number of individuals from each species. And so you can actually use the quadrat to measure biodiversity, and you do that. So for example, if I also had, if I also wanted to look at the presence of butterflies, right? Oh God, I have to draw a butterfly. Okay. The idea is that every time I laid my quadrat down and counted trees, I would also count cocoons or something, butterflies or caterpillars or whatever. Okay. And then I would come up with, in these different right, in all of these 6 areas, how many trees do I have? How many butterflies do I have? Or caterpillars technically. And so from that, and then you can compare and get an idea of, there might be more trees. And so the idea is that you would do this in 2 different areas. I would have a different field. So I would have one field where I'd say, okay, there's lots of trees, but not many butterflies. And then I could have another field where I would say, there's lots of trees and there's lots of butterflies. So that would have higher biodiversity. That's the idea. But the quadrat sampling and this approach is the same for regardless of whether you're looking at population versus biodiversity. If you're looking at population, you're only looking at a single species, right? For example, the trees. If you want to measure biodiversity with quadrats, then you have to start looking at more than one species, all right? Preferably 4 or 5. But the idea is that that's how you know if they're asking you a question, are they measuring biodiversity or are they measuring population, estimating population size? And so the estimations, are they looking at just one individual species or are they looking at multiple? One individual species, they're estimating population size. Many different species, then they're estimating biodiversity in an ecosystem or in an area. So that's quadrats.